modern science here. Okay, scientific revolution is going to happen in the 1600s, and of course, it's based off of movements that came before, intellectual and scientific accomplishments of the 1400s and 1500s, and even going back to the Greeks too. What were some of the influences here? Well, the mathematical and naturalistic skills of Renaissance artists were certainly an influence, moving away from the church and towards science. You had the old Hermetic belief in magic and alchemy that people were interested in, and that's going to kind of develop into new science. And the humanist rediscovery of Greek mathematicians and thinkers certainly get people into doing that thinking. And there was the inspired work of a few intellectuals that would spread throughout what becomes a new and emerging scientific community. Leonardo da Vinci believed that mathematics was the key to understanding the nature of things. This Renaissance man, this scientist, early scientist and artist and all of the above with him. And scholars devoted to Hermeticism saw the world as a living embodiment of divinity, where humans could use mathematics and magic to dominate nature. But the greatest achievements in science during the 16th and 17th centuries came in what we will talk about in this chapter: astronomy, medicine, and mechanics. A medieval conception of the universe here, of course, where the Earth was at the center of the universe there, and then the Copernican system, and we'll talk about him in just a minute. Copernicus is going to have the sun at the center. All right, so we're going to start off with astronomy, a revolution in astronomy. The geocentric universe had the Earth surrounded by 10 spheres, and the Christianized Ptolemaic universe, which was called the geocentric universe. The Earth was the center, and the sun revolved around the Earth. But then you get this guy, this Nicholas Copernicus, who comes along. He's Polish. He's doing a lot of his work right here at the turn of the 16th century. He writes a book on the revolutions of heavenly spheres. And he's a timid man. He's cautious. He's challenging this long-held view of the geocentric universe with something he calls the heliocentric universe, being that the sun is the center and the planets revolve around it. Now, his ideas were just about as complicated as those of Ptolemy, but obviously more correct than Ptolemy's were, as we know now. But Luther and other Protestants especially, who took the Bible literally, they condemned his discovery as contrary to their interpretation of the Bible. So there'll be some issues there, but it's not really going to affect him because he writes this book a year before he dies. Then you get Tycho Brahe, a Danish nobleman who built his own castle. He's granted control of this island, and so he builds this cool castle and stuff. And he makes this observatory, and he designs his own instruments and everything. He's making more accurate observations of the planets than, say, Copernicus did. And Copernicus wasn't truly an accomplished astronomer. He was really more of a mathematician. The math just didn't add up when he was studying the heavens. So Tycho Brahe is going to continue. He's going to build off of his legacy and improve it, which tends to be in the model that we get used to. Then you had Johann Kepler, who comes along, and he used data to derive his 3 laws of planetary motion that confirm Copernicus's heliocentric theory, but that show the orbits were elliptical. And that's why Copernicus's model was very complicated, because he continued with the Aristotelian idea that it was perfect circles, that orbits were perfect circles. With Kepler, he's willing to go even further and say, actually, the orbits are elliptical, sort of an oval shape. Then you get Galileo Galilei. What he does is, I don't know if we can say that he invents the telescope, but you had these Flemish lens makers who were making spyglasses and stuff that could see objects over long distances. So, they're using it for battle and stuff like that, and naval voyages. Galileo is going to point them up, and he's going to craft this new machine he calls telescope, and he's going to point them at the moon. He's going to see mountains and craters on the moon, and he's going to discover that there's 4 moons on Jupiter. So he's going to advance it even further. He writes a book called The Starry Messenger in about 615. Early on, the church wasn't too concerned with, say, Copernicus. But now that we're writing and we got the printing revolution already underway, and we have people writing in vernacular where common people can read it, it's becoming an issue. And the church has already been attacked enough. Remember, this happens after the Reformation. The church doesn't need any more attacks on their authority. So it was condemned by the church, and he was put under house arrest for the last 8 years of his life. Um, he writes this. First, he recanted on his Starry Messenger, which he wrote earlier. But later on, he writes his most famous work, which is a dialogue on the two chief world systems. And basically, he takes the Ptolemaic version and the Copernican version of the universe, and he compares them in this written dialogue. It's very clear through the dialogue that he supports Copernicus. The church has had enough. They put him under house arrest, and that's Galileo works on mechanics for the rest of his life under house arrest. So scientific leadership passes to England, France, and the Netherlands. You're going to start seeing it. It's going to move out west, basically. There's Kepler. And Galileo demonstrated his telescope. And then you get this guy, another big dog of the scientific revolution, Isaac Newton, Englishman. He was chair of mathematics at Cambridge University. He wrote Mathematical Principles of Natural Philosophy, or the Principia. And you know him for his 3 laws of motions. His discussions on gravity, and he is one of the inventors of calculus. Calculus was invented by a couple of different people independently of each other. And this calculus used to calculate motion, speeds, and things like that. Newton's scientific discoveries were readily accepted in England, but they were resisted on the continent in other places. And the planets obey the same laws as do the objects on Earth. Objects that stay in motion tend to stay in motion unless acted upon by an outside force. You guys have science, you know what I'm talking about here. All right, with a single law, that of universal gravitation, Newton was able to explain all motion in the universe. His great synthesis of the work of his predecessors created a new picture of the universe, one in which the universe was viewed as a great machine operating according to natural laws. It made people who believed in science, it made them feel comfortable because, we have laws, and they like that idea. Eventually, Newton's ideas will be challenged by people like Einstein, and today the world we live in, Einstein's views are challenged. It's incredible. Okay, so there's astronomy. Let's move into medicine here. So medieval medicine had always been dominated by the work of the Greek Galen, who had lived some 1,500 years earlier. And he's got these weird ideas. He'd never dissected a human body. He dissected animals and wrongly thought that the animals' anatomies would be the same as humans. So this led to some, things that didn't work really. But yet somehow he still managed to be the guy that Europeans modeled themselves off when it came to medicine. He's belief in the 4 humors of blood, yellow bile, phlegm, and black bile, as far as causing diseases and things and how to fix people. Then you get Paracelsus. He changes his name from Philippus Aureolus von Hohenheim. He changes his name to mean greater than Paracelsus, or greater than Celsus. He would fit in fantastically in today's society. He is incredibly vain. I mean, he changes his name to that. Very short-tempered. As such, people don't like him. He's a dose guy. You cannot handle him for very long. So he doesn't keep jobs very long. He keeps moving. He has to constantly move from town to town, from city to city. He and his followers use very careful attention to the proper dosage of their chemically prepared metals and minerals. He is very much against Galen. He thinks Galen's a fool. And his approach to healing people is different as such, and it's going to help advance medicine. Another is Andreas Vesalius. He writes on the fabric of the human body, which is a masterpiece on anatomical structure. He dissects a human body, and he learns a lot. He corrects a lot of Galen's errors. Now he keeps some things too that he just wasn't able to fully leave Galen's template, I guess. He challenges him on several things, but on two separate blood systems and things like that, he doesn't. But that will change with William Harvey, who continues off the work of Vesalius and writes on the motion of the heart and blood. He refuted the ideas of the liver as the beginning point of the circulation of blood, because from his studies, it's clear that it is the heart. You get another big one, Robert Boyle, who creates Boyle's law. The volume of a gas varies with the pressure exerted on it. He's also the first guy that says matter is composed of atoms. Obviously you can't see these atoms, little particles of all shapes and sizes. So it's a theory. Then you get Antoine Lavoisier, who is regarded as the father of modern chemistry. So what you see is willing to buck the trend, observation, to go against church ideas, things that have been around for a long time, and then mess up. And guys will come along later and study their works and realize that they messed up, and they'll make it better. Trend to this day. Women play a little bit of a role in the scientific revolution, thanks to the Renaissance and these new movements going on. There are a few opportunities for women. However, of course, it's only going to be for the elite. Most of their education is informal. It's dads and uncles, men who are willing to teach the women. So a lot of times it's not like they're allowed to go to a college and study. So they're getting informal educations, but they're making contributions nonetheless. You get Margaret Cavendish. Her observations upon experimental philosophy helps lay the groundwork for natural philosophy. She attacked the belief that humans through science were masters of nature, because some of the men in this time period are believing that with science we could become the masters of nature. And she kind of sees it as grandiose and wants to remind men, that we're not above nature, that nature will always triumph over man. You get Maria Merian, who's an entomologist, meaning she studies insects, and she writes The Metamorphosis of the Insects of Suriname. Why is that important? Because, well, people are reading her and taking her seriously, and she's an excellent illustrator. So she's able to draw really good pictures of it. It's, and it's influential in that way. You get Maria Winkelmann, a German astronomer. Her husband is also an astronomer. She discovers the comet when he goes to bed, and he does give her credit for it. So props to him. And because a lot of times in those time periods, men would take credit for their wives, many of them are incredibly intelligent, but they have to be non-public and behind closed doors. But he does give her credit. So she discovers this comet. However, she's rejected for a post by the Berlin Academy because they're still not willing to let women in. Women still seen as inferior. There she is. Her husband was 30 years older than her. Encouraged her to pursue her literary interest. She wrote plays, an autobiography, and a biography of her husband. So it says here, the autobiography and biography led one male literary critic to call her a mad, conceited, and ridiculous woman. I'm sure he was quite jealous. All right. So there's some illustrations by Maria Merian. As you can see, she's very talented. So she's able to make very good illustrations of the insects that she studied. Winkelmann here, the one who discovered the comet. All right, so we get a little bit of a debate over the nature of women. You get one of the scientists of the day, Benedict Spinoza, who believed that women were naturally inferior to men. And women in this time period and the time period before had always been portrayed as inherently base, prone to vice, meaning it goes back to Eve being the blame for original sin and all that. So women were seen as, easily swayed as such, like the serpent swayed Eve to, go into the Garden of Eden, and sexually insatiable women. Women joined debate in the 17th century and rejected this view. As you can imagine, they felt that they were certainly no more sexually insatiable than men, and that men were as easily swayed by vices as they were. Science was used to perpetrate old stereotypes about women. What we're talking about here is um, there were men writing books, and sometimes they would talk about how men and female skeletons were different, and that female skeletons had larger pelvises, which meant that they were, um, designed to give birth to babies, and they had smaller skulls, which meant that men were designed to be the leaders with bigger brains and all this. It's not true. Scientific revolution also reaffirmed traditional ideas about women's nature. So while women are making an impact in the scientific revolution, it's not the scientific revolution that's going to free women as far as it comes to equality and whatnot. All right, we get a little bit of philosophy here at the end. Towards a New Earth by Descartes, rationalism and the new view of humankind here. Rene Descartes is a big dog, very important. He writes a discourse on method. Um, I think, therefore I am, and he separates mind and matter, and that they are two separate things. And this comes into something called Cartesian dualism. He is labeled as the father of modern rationalism, and if you take a philosophy class in college, you'll probably study Descartes. Descartes believed that the world could be understood by the same principles inherent in mathematical thinking. And Descartes is going to play a role, of course, in the scientific method, along with Francis Bacon. Here he is. Reason is the only thing that can give you truth, according to Descartes. That was very important. All right, here's Francis Bacon. The foundation of his methodology was inductive reasoning. He rejected Copernicus and Kepler. He misunderstood Galileo. He said it felt like correct scientific method was built on inductive principles, and you have to proceed from the particular to the general. And he's going to take you through all the hypothesis and testing and observation and all the parts of the scientific revolution. And Isaac Newton would unite Bacon's empiricism and Descartes' rationalism. How did science affect society? People recognized science's rational superiority. Rather than have the old school supernatural issues of the church-dominated world, it was nice for science to study things and actually have it to provide proof. Science also offered new ways to exploit resources for profit. So yeah, the government's going to like science. The government's going to sponsor science. We're already in the Reformation, moving away from church control. We've got a separation of church and state, and science is going to give us ways to find new worlds, and science is going to find us new ways to improve guns. I mean, all of these things to exploit resources. And you get the birth of scientific societies, such as the English Royal Society. Begins very informal, just a group of minds meeting. Receives a formal charter in 1662 under King Charles II, but it did receive little government encouragement, and its fellows simply co-opted new members. You had a French Royal Society as well. Same story here. Chartered by Louis XIV in 1666, he was a patron of science and a patron of the arts. It received abundant state support. It remained under government control, of course, because that's Louis for you. He's an absolute monarch. Its members were appointed and paid salaries by the state. So there's good encouragement there for you to become a scientist. All right. Louis XIV and Colbert, Jean-Baptiste Colbert. Was it? It is not. All right. Conflict between science and religion doesn't go away. Still exists today. Scientists' beliefs triumph in this time period, and religious beliefs suffer because of it. But the war's not over between science and religion. It's kind of always a back and forth. There's times when science rules the day, and then there's times when people believe that we've become too sciencey and we've lost our way in the world, and we come back to God. And you have a religious awakening, if you will. You guys have had American history, so you know the Great Awakening as an answer to the Enlightenment, things like that. Now, Blaise Pascal We'll talk about him a little bit because he sought to keep science and religion united. He doesn't want a separation of the two. And there are plenty like that today. There are plenty of scientists who are also religious at the same time, although a lot of people naturally feel like scientists are atheists. That's not true. Some are, some aren't. He attempted to convince rationalists that Christianity was valid by appealing to their reason and emotions, and that Christianity is not contrary to reason, that the two can coexist, and that reason had limits. Humans cannot understand infinity; only God could. And if you think about that, that's pretty interesting. The concept of something going on forever without end is really hard for a rational human mind to wrap ourselves around. Spinoza believed that God was not just the creator of the universe, but that God was the universe. The failure to understand God, led to people using nature for their own self-interest. So, okay. And there's you a little bit of a timeline, so you can kind of way back here. He's one of the forefathers of scientific revolution, contemporary. Since we have astronomy, and here we have medicine. It takes a little bit, 50 years. We get Kepler. They're going to advance things, medicine in the human body. Francis Bacon is contemporary. There's a lot of action happening here in the first half of the hundreds. Okay, and Newton at the very end, scientific revolution here. Probably why his laws are longest before there's any kind of challenge to them. All right, you can see your review points here. These patronage of royal science centers, science becoming an integral part of Western culture in the 1700s. It offers new means to make profits and maintain social order. Remember, in Europe, we're always trying to maintain social order. And the scientific revolution was a major turning point in Western civilization. It's another thing that's going to help give Europe a leg up on the East. So there you go. Some discussion questions for you to look at and think. And we will see you in class. Hope you're taking